Behind me is the McLaren Elva. To understand what the Elva is all about, it's worth briefly talking a little bit about the aerodynamic history of our Ultimate Series cars. So the first Ultimate Series car we did here at McLaren Automotive was the P1, and the mission for that car was to be the ultimate car on road and track. And on track that car generated 600 kilos of downforce at 150 miles an hour, which back then, with its active aerodynamic system, was definitely a high watermark. The next car in the series, the McLaren Senna, it's a road-going car of course, but its brief is absolutely to be the ultimate road-legal car on track. Next came the Speedtail. That's a car that will do 250 miles an hour, 400 kilometers an hour. That means achieving very, very efficient aerodynamics, which means low drag coefficient. The McLaren Elva, it's a car, the concept of which is just for the pure pleasure and exhilaration of driving. When we talk about pleasure and exhilaration, and exposure in this case, that meant stripping the car of absolutely everything, including the windscreen. So effectively no weather protection at all. And that presented the aerodynamic challenge for this car. The idea for this car in terms of the aerodynamics was, with absolutely nothing between you and the wind coming at you, would it be possible to create a virtual canopy? And that was the challenge that we set ourselves. Inside here there's a giant hook-shaped duct. Air is channeled in the front of the car, which is the area where the highest pressure, obviously, as the car's pushing its way through the air. This air is all ducted and channeled through the center of the car and is turned through 120 degrees and actually exits the top surface in this direction. So it is fired out of here at very, very high velocity. Of course, there's onrushing air coming behind it, and that high energy channel of air that's being forced up here is bent back by the oncoming air and is effectively curved back all the way over the canopy. If you're sitting in the car with the system deployed at, let's say, 100 kilometers an hour or 120 kilometers an hour, you can sit here in relative calm. Your hair, if you have hair, is unruffled. And if you put your hand above your head, there's a certain point where you transition, and it's just literally like sticking your hand out of the car window at that speed. It's as dramatic as that. The system is actually boosted in terms of its performance by a gurney, which is here. This actually rises as a function of speed. When you start going faster and faster, the gurney rises. And the whole system can be switched off from inside the car. There's an internal flap that shuts the whole duct off.
My name's Andrew Kay. I'm Chief Engineer for the McLaren Elva. I've worked on lots of different projects with McLaren. Started with the 570, then the 720. I worked on the Senna, and now I get to be Chief Engineer for this car, which is just about the most exciting project I could have hoped to be a part of at the moment. So with the Elva, we wanted to make a really beautiful car, but also a really clean and simple car. So we've worked really hard between the engineering and the design teams to really minimise the number of panels and parts that we have in the car. So there's fundamentally only 3 really big carbon fibre panels that make up the extent of the car. So that's this large front clam, goes from side to side all the way back to the front of the door shuts. The body sides on left and right side make up the other 2, but it's meant that we've really been able to minimise the number of panel gaps on the car and given it a really, really clean and elegant look. One of the smaller panels that's small but extremely difficult to make, it's been really challenging, is this door outer panel, because it's not actually just the door outer. Here it incorporates part of the ducting system, which I'll talk about in a moment. You can see we want to make this as seamless as possible through this really complicated geometry. So it's incredibly difficult to make that in carbon, particularly as we've got this air path coming through it. There's actually 3 routes for air to come into the high temperature radiators. The high temperature radiators that cool the engine, they sit in here at an angle to the airflow. They're fed very obviously from this duct that's come along and been guided by these surfaces. The air stays attached to these surfaces and feeds directly in. That feeds the top, roughly 1/3 of the radiator. This duct that you see in the front of the door feeds the centre of the radiator, and the air comes in here, comes all the way through the door. It then has to jump from the door into the body side to complete its path to the centre of the radiator. There's then a third route that starts from just inboard of the front wheel and comes all the way through this section of the body side and feeds the bottom of the radiator. So 3 separate paths feeding the engine cooling. The active air management system has taken quite a lot of development. We went through quite a lot of different versions of the system before we found something that was powerful enough to give us the effect we wanted. We always wanted our target was to be comfortable at 70 miles an hour. And I remember the first time I drove the car with the current system on it. By the time we'd actually got the car together and working with all the features in it we wanted, it was about 2 o'clock in the morning. This is out in Spain where we do most of our testing. But still, 2 o'clock in the morning it's a hard time. And I went out in the car, and as I went past kind of 50, 60, 70 miles an hour, I realised we'd cracked it. It was a real eureka moment, and suddenly, yeah, this system was really working. I went above 70 and it kept working. Really, really liberating feeling. Really fantastic moment in the project, and not one I'm going to forget. So now we're at a point where we can drive along at 70, maybe even 80 miles an hour and have a conversation with the person next to you with your voice no louder than I'm talking to you now. And it enables you to connect to the environment in a way that maybe motorbike riders feel, but other than them, no one's felt anything like this. We were testing in Spain at our development centre the other day, and I could tell that they'd laid fresh tarmac on part of the circuit because I could smell it. Well, in our normal cars, that would have all been filtered out. You wouldn't have smelt it. So it connects you to the environment in a way that's completely unique. And I hope will lead to people enjoying the car and actually having really special memories, those drives that stay with you, that you remember for years afterwards. This is a car that's really made to make those memories, make those really special occasions.